Hey everyone, Dr. Dan here. Today we're going to set up a virtual reality network from scratch. So this is going to be a multiplayer virtual reality game. I'm going to show you the basics of setting up a network with Unity's unet system, so the Unity game engine and the unet system, and getting the Oculus OVR plugin to play well with that system so that we can be in virtual reality and be in virtual reality and see multiple people. So elsewhere I've gone into greater depth about networking behaviors, and elsewhere I've gone into greater depth about virtual reality, and in this video I'm going to bring them together in a very basic way that gives you a starting point for crafting and coding your own virtual reality experience that is multiplayer. But I'll get things moving around in a multiplayer network, moving independently of other players with multiple cameras, virtual reality cameras in there, and yeah, that should be enough to get you started with virtual reality networking. So the first thing we're going to do is go to the asset store, and we will pick up Unity or Oculus integration, and import that into our project. We want everything, and it's going to ask us to restart if a new plugin, OVR plugin, is available. If it is, go ahead and get it and restart Unity. Okay, once Unity's restarted, let's begin by setting up our network scene. So let's create a 3D object, a plane to walk upon. Let's drag it down a bit, maybe like -2 on the y-axis, so we don't have to mess around with our player when we spawn in. Let's save this scene as test net or whatever, and let's add this scene to build settings. Okay, next let's create an empty game object. Shouldn't be in plane. We can reset the transform, and on this game object let's add a network manager. Since we're just testing a network, we're not going to customize this network manager. We're just going to use the network manager HUD. Now let's drag that scene we saved into both our offline and online scene and save. Alright, at this point we can test the network if we want by just hitting play and hitting LAN host, and we'll get an exception because we haven't created a player. So let's create a player that will spawn into this network. First of all, let's raise this game object up a bit, and actually let's make a new game object and raise it up a bit. Let's call this one, just so we can keep track of them, net manager, netman, like Batman, netman, okay. And this can be our spawn position, and maybe like down at 0.72 since the plane was so low. To make sure we spawn there, we'll add a network start position to that. And then let's start making our player. So it is tempting to just drag the in Oculus VR prefabs we have a OVR player controller, and it's tempting to just drag that in to our scene and make that our player prefab because it has a player controller. And if you test it out, so let's let our network manager know that that's temporarily going to be our player. In spawn info, let's drag that over to player prefabs and So a couple of things happen. First of all, we get kind of nice movement, right? I can even put on my virtual reality headset and show you as I look around. So we get a nice player controller. However, if we spawn that over a network, because the OVR player controller that gets spawned has a camera rig, which has a OVR manager, we're going to get a whole bunch of errors. We're going to get the headset camera jumping from network to network, and the player controller isn't going to work, or it's going to control both players. So we can't actually do that. So instead, I'm going to start taking things off of this player controller. First of all, we're going to have to write our own character controller. So we're going to remove OVR player controller and character controller from this. Just so I don't get my prefabs confused, I'll call this network player. And drag it into assets. Now, in OVR camera rig, we're going to remove the OVR manager, and we're actually going to put that, because that is a singleton, there only needs to be one of those per scene. We're going to put that on, let's just make an empty game object. And we'll call this OVR. VR man. Okay, so we'll put our OVR manager there. Now this camera rig, we also don't need a headset emulator, we just need the camera rig itself. Alright. So on network player, I don't want debug info, so I'm going to remove that. And I don't want sample scene controller, I'm going to remove that as well. So now we just have a forward direction and an OVR camera rig. Alright. So our network player, in order to have hands, we're going to make some cylinders here. These are going to function as our hands. And I'm going to uncheck capsule collider on that cylinder, and I'm going to scale it down to something like 0.1. And this cylinder will, for testing purposes, be our left hand, and this one will be our right hand. And while we're at it, forward direction we also don't need anymore. While we're at it, let's just make a sphere or something. We don't want it parented there. And we'll just call this our body. And again, we'll turn off the sphere collider for now. For the scale on this, so my hands are actually quite small. Let's set this to like 0.4, 0.6, 0.4. That look kind of like a body? Kind of. Alright, good enough. Let's make a new material so that these elements stand out, and we'll call this player. Like blue. Okay. And let's make another material for our hands. And save it. Alright, finally, so there's our OVR camera. Finally, let's add, so this needs to have a network transform. And we want to, yes, sync the transform here. And we're also going, and that by default gave us a network identity. We want to click local player authority because this is our local player. And then let's add 3 network transform childs. 1, 2, 3. And we're going to link these the body, the left hand, and the right hand there. And let's save that. Let's hit apply to apply that to our prefab. And then finally, let's add one component, which we'll just call local player control. Okay, so that is all the components that we're going to need there. Let me hit apply one more time, and let's start modifying this local player script. Alright, so the first thing we're going to need here is a public game object, OVR camera rig, a reference to our camera rig, and then we want a public transform, left hand, public transform, right hand. So those will be our hands. We need a public camera, left eye, public camera, right eye, and a vector 3 for our position. Does that need to be public? No, it doesn't. Vector 3, pause, and in start, we'll set our position equal to transform.position. And then in update, we want to check if we're the local player. So we're going to need a couple more things here. In order to know if we're the local player or not, so if we are the local player, we're going to use our camera, move around, all that nice stuff. If we're not, we don't even want to know about the other player's camera, because that's going to confuse the OVR plugin and your network. So we're just going to destroy that whole camera. So in order to know if we're the local player or not, we need to be using Unity engine dot networking. And this needs to be a network behavior. All right, and in update, we will say if we're not the local player, destroy our OVR camera rig. Else, now we'll do a whole bunch of stuff. So, and this is all in update, right? So else, the first thing we're going to do is say if left eye dot tag. So sometimes when a new player gets introduced, if we want to destroy their camera rig, but it can pull the tags of our main camera over to them, our camera appears to be transported to the other player as they join our network. So to get around that, we'll say if our camera tag is not main camera, we'll say left eye tag equals main camera, and we'll just double check that we are enabled, and we'll do the same for right, and that will take care of the very tricky to get to figure out, for me at least, issue with cameras being transported as players join the game, or shut off, or something weird happening. All right, so that takes care of our camera when other player joins. All right, now we have an issue, which is that our So over in Unity, here in our OVR camera rig, you'll see we have tracking spaces. And in those tracking spaces, we have that left eye anchor. This is what needs to be the main camera, and right eye anchor. So in our tracking spaces, in our center eye as well, you'll see we have a audio listener. Let's shut that off, and on the main camera in the scene, let's just, we can leave the camera there, but we'll shut off that audio listener as well. And so when you normally play a Oculus or develop an Oculus game, your left hand and right hand anchor are tracked through a interconnected system that has to do with the camera rig. So if we destroy this, we also destroy our left hand and right hand anchor being tracked to where our hands actually are. So we need another way of handling that. So the way of handling that is to use Unity XR nodes. Oops. Alright, so we're going to be using input tracking, which will be from our Unity XR input tracking namespace, and node from our XR nodes here. And then an update after we finish taking care of hand position tracking. After we take care of our cameras, we're going to take care of the hand position tracking by saying our left hand first dot local rotation equals input tracking dot get local rotation, and we'll do node dot left hand, and we'll do the same for right hand. Right hand dot local rotation equals input tracking get local rotation node right hand. So this is how Oculus actually finds out in Unity where the position of its controllers are, is by using unityengine.xr.xr node and unityengine.xr.input tracking. So by looking through the Oculus code, I discovered this solution. So left hand dot local position now, same trick, right? Input tracking dot get local position node. What are we on? Left hand? Left hand. And right hand position equals same thing. Input tracking get local position node right hand. Okay. So that'll take care of our hands and their movement. We'll set their position and rotation to whatever our hands are at. Alright. And so finally, handle position and rotation of player. Again, we want to do this independently of any of relying on any prefabs, OVR camera rig, controller, player controller, whatever, because we want this to be something that can communicate over a network without cluttering that network up with a bunch of scripts that may or may not call each other. So we're just going to set a vector2 primary axis equal to OVR input dot get what do we want? We want the OVR input dot controller. Nope. So we have a thumbstick. Axis 2D dot primary thumbstick. Right, will be our input axis 2D primary thumb. And then we'll do some if statements. So once we have that primary axis, let's see if our primary, so that's our joystick on our left controller typically. So we'll say if our primary axis dot y is less, well, let's do greater than first, is greater than 0f, 0 float. Then we'll set this position vector we have here to plus equals, and in here we want our primary axis y primary axis y times transform forward, because we want our when we move forward we want it to be in the direction that we're facing, because we're going to handle being able to rotate with the other thumbstick, and then time dot delta time. If we're pushing back on the left thumbstick, then our primary axis y is going to be less than 0f. And so if that happens, again, we're going to add to our position. Here we're going to add our mathf dot absolute value, because otherwise we'll get a negative one of our primary axis y, times, and we want the negative value of our transform forward times time dot delta time, because we want to move backwards. Time dot delta time. All right. And we're going to do the same for our x, except it'll be transform dot right, and primary axis x, and negative transform right. Yeah, okay. And finally, we'll set our position, our transform position equal to position. Okay, that's going to handle our movement. Now we need to handle rotation. So to do that, we're going to have a vector 3 Euler. I'm not spelling that right, am I? Euler equals, let's see, what do we need? Our transform rotation dot Euler angles, which will return a vector 3 of our current rotation. And then we want a vector 2, so our other controller will handle our rotation, and we'll call it secondary axis, and we'll set that equal to OVR input dot get OVR input dot axis 2D dot secondary thumbstick. And we'll set our Euler.y to whatever we're getting for our secondary axis, y value. And then let's set our transform.rotation to our Euler I guess we don't really need those. And that is it. We might have to tweak this. Maybe set local rotation to transform local. Can't remember if I needed this or not, but just to be safe, let's set it as well. Quaternion, Euler. Alright, and that is our custom player controller. And notice that all of this rotation and input and player hands is nested inside the if we are the local player. So it's never going to happen to something that is the local player. All right. So at this point we can start to test this out. So player network. Let's apply everything. Oh, that's the wrong one. Unity projects open here. There we go. Network player. That's more like it. Alright, so network player still needs to know about a few things. It needs to know what our OVR camera rig is. The whole thing's just going to be destroyed if we're not the local player. What's going to remain is our body. Oh, which we don't even need a reference to. What's going to remain is our body, left hand, and right hand. So here's our left hand, and here's our right hand. And then we also need a reference, if we are the local player and this doesn't get destroyed, to our left eye anchor camera and our right eye anchor camera. And Unity's smart enough to know, because we declared those variables as cameras, that they are cameras when we drag them over in the editor. Alright, that's it. So let's apply that. Let's delete that from the scene and save. Let's run play and run it locally. So run it on LAN host. Oh, and we have still not got a network player. So let's make sure that this network player is known. Alright. So here we are. Putting on the headset now. You can see in the bottom left of my screen. And there are my hands going. One hand anyway. There's the other. Alright. So, I have to kind of get creative about these hands. They're not, perfect. We could obviously put in any kind of model we want for hands. There's the body that I've set. So now I can move my rotation around, and as I go forward and backwards, I move in my forward direction, hopefully. I may need to tweak a few things here. So yeah, as I move my rotation, I get movement in the forward direction. So, cool. All right. So one thing I noticed was that we actually want the secondary axis X value here, which is a little confusing. So we're setting the vector 3 Y rotation to whatever our X value is. So if we move left, we want to rotate around the Y axis. We did have it set to Y, but we want that actually set to X. That is the only tweak I want to make before we oh, one last thing too. Let's just have a public float for speed, because we were moving kind of slow there. And we can set this so that speed always gets added here. Yeah. And let's just make sure that that isn't ridiculously fast. So if I hit play now, let's test locally before we test on a network. hands. And moving much faster, and always moving around the rotation that I want. Okay, good. Cool. So we're ready to test over a network at this point. To do this, to test this, we need a second PC and a second Oculus. So first thing we'll do is this is a good practice for testing. Make sure that you've shared with, so if you right click in Windows and you share with specific people, you can share with a computer name that's on your local network. You can also do it by home group if you're not locked down in a domain. So I have this whole folder shared, my whole documents folder shared, and that's going to make testing a lot easier and debugging a lot easier. So just a good practice to have when you're testing VR stuff. First of all, you need to spend the money on two, or find a way to get two Oculus and two computers set up. There's just no easier way to test, unfortunately, at this point, that I've found without losing some elements of realism. So anyway, to test, we need to build. So we're going to go to Build Settings, and we'll build, and let's make a new folder here called Build, and in there, let's say testing, and that will build, and we'll just make sure we get a success. Alright, we did. There's our testing executable. So I will switch at this point to, it's very flattering, camera, and you can see over here barely that I have another computer set up and another Oculus headset set up for testing. So let's fire that up over here. This is my shared folder. There's testing. I'm just going to double click on that. And let's run it. And it's going to run the HUD right out of the box. The network HUD. So we're just going to click on, well, it's probably going to warn me about file sharing. So sometimes you have to put the headset on to get things started. There we go. It's going to warn me that I'm over a private network and I need to allow access. That's fine. Alright, so there's my remote host. I don't know if you can see anything, but yep, there are my hands. Alright, so I'm just gonna test my movement out and switch my hands around so that I have the right hands. There we go. Okay, so everything's working fine. When we have a single player connected, I'm gonna move into the corner of the room. Oculus shuts off unless it thinks there's a head in there with a little infrared. So to trick it, I'm going to just block the view. And over here, I will switch back to screen. Alright, so now to test this network, first of all, let's close build settings. I just ran right in the editor with the code with the play, and I'll type my IP in here. Don't look. And of course, you can handle all this with lobby rooms if you or custom lobby rooms if you want. When you develop your game, this is just for testing, so we're fine with that. Alright, seeing some camera jankiness. So let's see what's going on here. Alright, so we do not have a second camera in there. We destroyed that. There's us. We're that OVR camera right there. There's our camera rig and our body and our hand. And I'll just go into VR to test things out. Alright, so now if I get my hands in the right hands. Okay, there we go. Now I can see the other player. Cannot see their hands because the hands have deactivated. So let me deactivate them there. Okay, and you'll see they're kind of janking around a bit. That's interesting. So we will have to fix that. But my hands are moving. The other player not seeing hand movement yet. Okay. And if we switch now to over here, you'll see that these hands, maybe you'll see, these hands are moving the other player's hands in sync, which is not what we want. Okay, so let's fix that. Alright, so let's see what that strange doubling up of controls was. What I did is actually I just dragged a network manager here, network player, into the scene, and I'm just going to test locally with LAN host and see what happens. So it should detect this is not a camera, and we have a camera, right? So there are our hands in the VR, and we can move around independently. Let's make sure we still have references to all those things. Left hand, right hand, good. Alright. So I'm actually just going to delete this from the scene. And let's put a cube in here just to keep track of things. Okay, and let's build again. I will start running this over here. Type in the IP again. And then let me switch to these headsets do wonders for our switch over here. Folder, VR, networking, network tutorial, build. Let's run that. See if we can't figure out what's going on with these hands. I believe it might have been that initial network error we got when we got a warning. I think it messed up our connection. So let's see here. We want host. Alright, let's make sure everything cube here. My right hand battery is dying. Okay, so right hand battery's dying. That may bail in a second, but good. Everything's working. So far, so good. Let's trick that out, and let's switch back. Connect as a client. The first thing I'm going to check for is there any jump in the camera? And as you can see, there is not. So we're not moving two cameras around with one headset. That is very good. Alright, I'm in VR now. And I see the other player. I see the hand that disappeared because of the battery life, so that's gone. But there's the other hand, and as you can see, I can move around without that hand moving around now. And if we switch here to the game network, there, from the other perspective, is me moving around without the other player moving around. So there's their hand, here's mine. I can move their hand around, right? And mine do not move. So cool. All right. So that is the basics of setting up a network with interactivity. I will certainly make this code available. I think it's a great starting point for networking virtual reality for anybody. In a later tutorial, I will cover how to sync a transform rate over that network. Sync an animation state over that network so we can have nice animated hands on every OVR controller. But how to do that should be pretty clear. You just need an animation that gets triggered whenever OVR input whatever the trigger is that or button is that you're interested in gets pressed. You fire some animation and sync it across the network. From this starting point, you can also add models that are hands, models that are bodies, and those can move around and change as your transform changes. And the cool thing about this setup is they can change independently of the other headset. Everything's not tied to two headsets, and I guess just be aware. We saw that if you get a warning about the network that you're joining being private and you need to allow access, you may get some initial network issues. So just run it again, make sure it wasn't that caused the issue like I did, and if not, start debugging. And this is a great setup for debugging, just having two computers on a local network with file sharing so you can quickly build it, run it on the other computer. This was vital for me to figure out how to get around not being able to simply have like avatars and player controllers from the Oculus sample scenes as a player that you then sync over a network. If you try and do that, you're going to run into a lot of problems, even though it's tempting because they have nice avatars. You wouldn't have to do the animations yourself. I recommend at this point against it. We'll see where their API takes them in the future. So that's all. Like I said in a later tutorial, I'll cover some more networking interactivity so we can add to those hands, since they're colliders, right? As well as other things, mesh. We can add interactivity by just having OVR grabber scripts on and grabbable objects in the scene. We can add animations, like I said, and lots of other VR elements at this point. As long as you're not relying on the camera rig prefab to get those things done, you should be alright. I hope that was helpful. I'll see you next time.